Okay, so we're going to, in this video, we're going to go over the unit circle and the sine and the cosine. And cosine. Okay, so we're going to start with just drawing ourselves a unit circle. Alright. Now, a lot of these properties can be defined with circles that are not of unit radius, or in other words, not a radius 1, but it just makes the calculations just cleaner where we don't have an extra factor of r kind of trailing along. So just keep that in mind. The unit circle is a convention that we use here. But as we saw when we were covering radians, right, the angle theta swept out, did not depend on the radius itself, right? It was a ratio of the radius and the arc length. Okay, so a unit circle, right, its algebraic equation is this, right? Radius 1. Right? 1, -1, and -1 right there. Okay, so this is a relation, right? Not a function, right? As we can see, it does not pass the vertical line test, right? But a relation between x and y, right? Where the pair of x and y that when you square them add up to 1, give us this equation of the circle. Okay, so what we want to do here, this idea behind the unit circle and our trig functions is if we have a point P, right, and again angle in standard position, angle theta, right? So if you have this point P, right, usually we call the point X and Y, and that would be in our standard coordinate system, right? But that's not what we want, right? What we want is, here in this case, we want to associate P with an angle theta. All right, and that association happens to be what is defined as the cosine of theta and the sine of theta. Right, cosine theta being the x-coordinate, sine of theta being the y-coordinate. Right, that is the association between this point on the circle and this angle theta. Right, so for example, let's do some examples here. All right, so for these examples, I want to find sine and theta, find sine theta and cosine theta for the following angles. All right, the first one, let's let theta equals to -3 pi over 2. Okay. All right, so let's just start off by drawing the angle, 3 pi over 2. All right, in standard position, remember, unless otherwise stated, we'll assume all angles are in standard position. So x, y. Negative, so we're going clockwise, 3 pi over 2. This is 1 pi over 2, 2 pi over 2, 3 pi over 2. So that would be our angle theta. All right, and let's say we had our unit circle here. All right, so on the unit circle, this is, remember, this is 1. This point is x-coordinate is 0. Y-coordinate is 1. Okay, so based off of that point right there, sine of theta, well, let's write sine of -3 pi over 2, right, corresponds to the y-coordinate, in this case 1. Cosine of -3 pi over 2 corresponds to the x-coordinate, and that is 0. Okay, so that's how we would generate or find the sine and cosine for this particular value. All right. Okay, let's do another example. Let's say for B, example B, let's let theta equal to pi. Okay, so let's start off, let's draw the angle on our in standard position in our coordinate system. All right, positive angle, so that means we are going in the counterclockwise direction. So that is our theta. Okay, and let's just draw in our unit circle. Oops. All right. Okay, so on our unit circle, right, this point out here is -1, 0. Okay, so we have the cosine of pi equals to -1, and the sine of pi, again, right, looking at the coordinates, is 0. Okay, so examples A and B are examples of what are called quadrantal angles. So -3 pi over 2 and pi are quadrantal angles, right? And then what makes them quadrantal angles is that their terminal sides lie on x or y axes. Okay, and again we could see those are easy because it's either the coordinates are either out here, which is 1 0 0 1 -1 0 or 0 -1. Right, those are pretty straightforward to calculate if we have a quadrantal angle. So what happens if we do not have a quadrantal angle? Well, as it turns out, if it's a special type of angle, we can calculate it rather easily here using some geometric triangles. All right, so let's say here, let's do example C here, and let's let theta equal to pi over 4. All right, so let me draw my axes and I'll draw my unit circle. Draw a unit circle here. Okay, and pi over 4 in our first quadrant, it's about 45 degrees, so midway in between there. And let's call this theta there. Okay, so that is our theta. So I'd like to figure out what are these coordinates here, and then once I do that, that'll be easy to figure out the sine of theta and the cosine of theta, right? So the way we're going to do that is we're going to use some right triangle. All right, so we could see that just dropping the this here parallel to the y-axis, right? This side here will be y. The side here would be x, right? The length of it. All right, and the hypotenuse here is always 1, right? Because again, we're dealing with the unit circle, right? So it's a radius, right? So the radius we know is always 1. So let me kind of draw this triangle here a little larger here, just to we could be able to work with this here. So right triangle. Again, this is pi over 4. If this is 90 degrees or pi over 2 radians, recall that the total sum has to be 180 degrees or pi radians of the angles in the triangle. So this also has to be pi over 4. Right? This is length 1. This is x. This is y. Right? This is also known as a 45, 45, 90 degree triangle. Okay, now another kind of property from geometry here is that if we have two angles that are the same, what must also be true is that the corresponding sides to the angle, the sides opposite the angle, they have to be equal to each other. Right, so let's just call it S. And now let's use the Pythagorean theorem. Right, we have x squared plus y squared equals to 1, or simply the equation of the circle here for a particular x and y. I'll plug in s. S squared plus s squared is equal to 1, or 2s squared equals to 1. And solving for s is equal to 1/2 s. Now here we be careful here, right? When we take the square root of a square, always remember plus or minus. Square root of 1 is 1. Square root of 2 is 2, right? We'll keep it exact, right? Otherwise known as root 2 over 2 if I rationalize the denominator. Still plus minus, right? And now it's like, well, which one is it? Is it plus or minus? Is it both? Well, let's determine here for this particular angle, it is in quadrant 1. So x and y is always positive. So this will be root 2 over 2, right? The positive value. All right, and s is the same for x and the same for y. So I have now found the point here. Right, the point is root 2 over 2 for both the x and the y coordinate. All right, and now it's simple here. The cosine of pi over 4 is root 2 over 2, and the sine of pi over 4 is also root 2 over 2. Okay, and that's how we would find it for this special angle, pi over 4, right, or 45 degrees. Okay, there are two other special angles. Let's go over those. The next one is, let's say theta is 30 degrees. So we'll call this example D, and we'll let theta equal to 30 degrees. Okay, so again, let's just start off drawing our unit circle. Okay, so 30 degrees is, let's just kind of estimate somewhere right there. So we'll call that theta. Okay, and again, I'd like to find the coordinates of this point right here. All right, so let's take a look at what does the, let's kind of enlarge our triangle here. All right, and again, similar as in the previous one, the length here is x, the height here is y. So here we have x, y, right, and this is 30 degrees. that is 60 degrees, right? Because again, all the angles need to add up to 180. This is 90, and 60 plus 30 is another 90. Okay, and then this is from geometry, another special triangle, 30, 60, 90 degree triangle. All right, now the way, and again, the hypotenuse, always 1. All right, now the way I find out, calculate what x and y is I take a look at a bigger triangle. So what I have here is half of an equilateral triangle. So let's say that we had here, right, where this will be 60, 60 if I think of this bigger triangle, and I kind of split this in half with a perpendicular bisector. Right? And since all the angles are equal, all the sides are equal, in this case 1, and here the whole length of this is 1, but since I cut this in half with this bisector here, the y is actually 1/2. All right. Well, what is x? Well, now I can use my Pythagorean formula, or in this case, the equation for the circle. And I don't know what x is. I want to find that out. So let's just call it s again, like we did in the previous one. Y, I know it's 1/2 squared equals to 1. Okay, and then here we have s squared is equal, excuse me, let's take a step at a time. S squared plus 1/2 squared is 1/4 equals to 1. Subtract 1/4 from both sides, and we get s squared is equal to 3/4. Take the square root, and again, square root of a square plus minus 3/4. Simplifying, plus minus root 3, root 4 is 2. Right, and again, what do I choose? Plus or minus? We're in quadrant 1, always positive in quadrant 1. Right, the x and the y are both positive. Okay, so now we have our point, right? The s, which corresponds to our x coordinate, is root 3/2, and the y is 1/2. Okay, so now we have here the sine of 30 degrees is equal to 1/2, and the cosine of 30 degrees is equal to root 3/2. Okay, so up next is our last special angle, and you guessed it, it'll be 60 degrees. So we're going to kind of flip everything on its side there. All right, so let's see here. Alright, so our last angle here is theta equals to 60 degrees. Example E. Alright, so we'll start again, unit circle. And 60 degrees. Right, closer over here to 90, so let's just call that 60 degrees. Theta, and again, same idea here. So when we draw this out, this is 30 degrees. This is 90. And again, hypotenuse, always 1. All right. And I've already solved it in the previous example, right? The side opposite 30 is 1/2. The side opposite 60 degrees right, is √3/2. Right, so the point, flip around the coordinates, 3/2. All right. Okay, so that one was, once we did the 30, 60, 90, and this is also 30, 60, 90. Now we can find the cosine of 60 degrees is 1/2, and the sine of 60 degrees is √3/2. Okay. All right, and those are just some of the basic angles, or special angles, I should say, 30, 60, 45, and quadrantal angles that should be easy to calculate, right? Like pi/2, that one should be easy to calculate if it lies on the x or the y-axis. Okay, so the next thing we'll cover here is we've kind of used it already, but let's kind of formally introduce it, is the Pythagorean identity. Okay, so the Pythagorean identity, if we had a unit circle, again with, this is the equation of the unit circle, and an angle theta, whether it be here or a larger angle, maybe somewhere out here. And if that angle is out there, right, whatever the coordinates of these points are, right, x, y, they always must satisfy whether x, y is here or here, right? They always satisfy this relation between x and y. X squared plus y squared equals to 1, right? But what have we shown? That x is actually equal to cosine of theta, y is equal to sine of theta. So what we can do here for our equation, if we substitute, we have cosine squared theta plus sine squared theta is equal to 1. And this is our Pythagorean identity. All right, so this will be true for any value, any point that lies on that unit circle. I can always relate the cosine and the sine by their squares summing up to 1. Okay, now this is going to help us. Let's say that we need to find the cosine and the sine, or the sine of an angle that is not quadrantal, or it's not even one of those 30, 60, or 45 degrees. All right, so now let's go over an example of how to do that. Okay, so let's say in this example, I'm going to be using the Pythagorean identity. Let's say that we're given if pi is less than theta, but theta is bigger than 3 pi, excuse me. let me rephrase that. If theta is less than 3 pi over 2 or bigger than pi, with the cosine of theta equals to negative root 3 over 3, find sine of theta. Okay. All right. So now let's look at the piece of information that is given to us and see how we can go about doing this, right? So, well, first of all, the sine of theta, we have cosine. So this should be, right away we could say, all right, I can use the Pythagorean identity, right? Cosine squared theta plus sine squared theta is equal to 1, right? And again, I'm not after the theta itself, right? I'm actually sine of theta, right? The actual value of, or how large the angle is not required here, just the sine of it, right? The relationship between that point and the angle theta, right? The sine function. Okay, so I plug in my value here. I don't know sine of theta. All right, and now I just simplify here. All right, so here we have negative squared is going to be positive. Root 3 squared is 3. 3 squared is 9. All right, plus sine squared theta equals to 1. Okay, and now I'll subtract 3/9. Okay. I'll subtract 3/9 from both sides. So we have sine squared theta is equal to, let's see, 9/9 minus 3 is 6/9, also known as 2/3. Okay. All right. And then I'll take the square root of both sides here. Now again, here, remember when we take the square root of a square, don't forget the plus minus. Right. We can write it like this. We can also rationalize the denominator, and we get plus or minus root 6 over 3. All right. Okay, now the question is it plus or is it minus? Well, I need to choose. How do I make that choice? I know the cosine is negative, so is the sine also negative? Well, the answer to that is maybe, right? That's where I use this other piece of information, right? Theta lies between 3 pi over 2 and pi. So drawing, here I'll just draw my coordinates, right? Pi is here, right? Radians, the theta, 3 pi over 2 is here. Right, so theta lies somewhere in here. All right, somewhere in there. The only thing I need to know here is, well, in this quadrant here, x is negative and so is y, right? So that means that the choice here is sine of theta is negative square root of 6 over 3. Okay, thank you.